This study delves into the impact of decoding methods on the alignment between large language model, LLM, generated and human conversations. Focusing on beam search, top K sampling, and nucleus sampling, the investigation assesses their effects on alignment in terms of substance, style, and psychometric orientation. To evaluate these aspects, novel measures are introduced and applied to 2 conversation datasets. The experimental results reveal that beam search's alignment improves with fewer beams, while nucleus sampling benefits from lower values of P. These findings underscore the importance of considering the context of the interaction, particularly in task-oriented and open-ended datasets. This context-aware approach is crucial for achieving better alignment between LLM-generated and human conversations. By examining the interplay between decoding methods and conversation alignment, this study provides valuable insights for developing more effective large language models. The introduced measures and experimental framework offer a foundation for future research, enabling the development of more sophisticated conversation systems that can engage in more human-like dialogue. The authors investigate the alignment between chatbot outputs and human-like responses, hypothesizing that adjusting decoding parameters can enhance the naturalistic appeal and user engagement of chatbot conversations. They employ a novel methodological approach, analyzing the performance of conversational language models, LLMs, through experiments involving real human conversations. The authors contribute 2 new parallel corpora of synthetic LLM-generated conversations, curated through turn-by-turn prompts with real-world dialogues sourced from 2 human-human datasets, Bolt and Craigslist bargains, collected across a variety of decoding methods. They also introduce new metrics for measuring LLM alignment to human conversations in substance, style, and psychometric orientation. This research tunes an empathy classifier on a dataset of 1860 short annotated texts to measure empathic concern. The study compares decoding parameters for language model-generated utterances, including beam search, top K sampling, and nucleus sampling, to optimize empathy and alignment in generated text. The analysis focuses on the cross-entropy score between human and language model-generated utterances, seeking the best configuration. The results show that using 2 beams outperforms the base greedy decoding strategy, while nucleus sampling with lower p-values, specifically between 0.6 and 0.7, achieves the best performance. Top K sampling with various K values performs similarly to the base method. Notably, a plot of scores as a function of conversation length reveals that the language model's performance improves with longer conversations for certain parameters. These findings have implications for improving empathy and alignment in language model-generated text. By optimizing decoding parameters, the study demonstrates the potential to enhance the quality of generated responses, particularly in longer conversations. The research paper examines the impact of decoding parameters on the quality of conversations generated by large language models, LLMs. It focuses on 3 decoding methods: beam search, top K sampling, and top P sampling. The study uses LLMs Llama 2 and Llama 3, evaluating their performance on 2 datasets, Bolt and Craigslist bargains. The results indicate that the choice of decoding method significantly influences conversation quality. Beam search consistently outperforms the other methods in terms of alignment with human-generated conversations. Top K sampling shows no significant correlations, while top P sampling exhibits positive correlations for politeness, negotiation, and verbosity. The study highlights the importance of context and the number of turns in a conversation. Increasing context and reducing turns can lead to better alignment. The broader context of the datasets also affects conversation quality, with Bolt showing higher adaptability and Craigslist bargains requiring more negotiation, leading to higher performance in terms of alignment and other metrics. In contrast to Craigslist bargains, Bolt's conversation structure is more open-ended, allowing for diverse dialogue directions. This lack of structure leads to more deviations in the large language model, LLM, and decreased alignment performance, as reflected in the quality metrics. Experiments reveal that lower p-values improve instruction adherence, while top K sampling has a smaller impact compared to nucleus sampling. The optimal decoding method for human-aligned conversational LLM output is likely a combination of low p nucleus sampling and beam search with a small number of beams. Increasing the number of beams can compromise alignment by introducing obscure words and longer texts into the sequence. Notably, this research focuses on two specific aspects of style, politeness and negotiation, which may not generalize to other facets of style or datasets. Future work should expand on these experiments to address these limitations. The methodology for computing empathy and self-concept metrics, as detailed in the paper's appendix, involves training classifiers on annotated data using Microsoft's DeBerta v3 large model. For empathy, the classifier was trained on the News Empathy dataset, achieving a validation F1 score of 0.71. In contrast, the classifier for self-concept was trained on a dataset annotated from the Bolt dataset, resulting in a validation macro F1 score of 0.83. The appendix also explores the impact of instruction fine-tuning on the Llama 3 variants, revealing identical trends with and without fine-tuning. Notably, the model without instruction fine-tuning shows larger improvements in alignment when using decoding methods. Furthermore, the justification for using cross-entropy scores is explained, highlighting its application in computing stylistic and psychometric measures. Table 2 presents a comparative analysis of Llama 3 and Llama 3 Instruct's performance across 6 psychological metrics: politeness, negotiation, self-concept, empathy, verbosity, and semantic similarity. The results are shown for varying decoding parameters, including beam size, p-values, and k-values. For Llama 3 Instruct, the scores range from 0.093 to 0.104 for politeness, 0.087 to 0.111 for negotiation, 0.665 to 0.668 for self-concept, 0.516 to 0.570 for empathy, 0.203 to 0.240 for verbosity, and 0.606 to 0.646 for semantic similarity. Similarly, Llama 3 shows a variation in scores from 0.082 to 0.115 for politeness, 0.073 to 0.111 for negotiation, 0.642 to 0.669 for self-concept, 0.621 to 0.682 for empathy, 0.141 to 0.228 for verbosity, and 0.462 to 0.507 for semantic similarity, all dependent on the decoding parameters. These findings underscore the significant impact of decoding parameters on the language model's performance across the specified psychological metrics.